Today also we are with a new video, and my name is Asif Ameer, and this is my contact number 830554. So today we are going to discuss 2015 A level combined maths, Pure Maths specifically question number 11. So the top part is going to be quadratics, and the bottom part is remainder and factor theorem polynomials. Remainder slash factor theorem. Okay. So by far, if you consider the recent history of A-level exam, 2015 is one of the hardest papers. 2015 they have designed the paper specifically to be a little hard. Okay, so we'll see how we are going to discuss this. First of all, read the question well. They are telling you 11a polynomials fx, gx and hx of degree 4 in x are given as follows. So you have question 11 part A. Fx, gx and hx is given. So we'll write fx. This is x to the power 2 minus. Now the question is a little wrong there. They have given you ax. It should be alpha x plus 1. And x to the power 2 minus beta x plus 1. Where alpha and beta are real constants. Then gx, they are giving this as 6x to the power 4 minus 35x to the power 3 plus 62x to the power 2 minus 35x plus 6. Then hx they are giving as x to the power 4 plus x to the power 2 plus 1. Then they are asking you Roman 1. If both fx equals 0 and gx equals 0, if both of them have the same root, have same roots. Show that the quadratic equation with alpha and beta as its roots is given by 6x to the power 2 minus 35x plus 50 equals 0. Okay. When two polynomials are having same 0, when two polynomials are having, when two polynomials are equals to 0 and if they are having the same roots, which means the deduction that we can get from this is that one polynomial is either equal to the other polynomial or one polynomial is an integer multiple of another polynomial, which means one polynomial multiplied by a real number or a number, okay, will give you the next polynomial. Now, since if you consider the leading coefficient of gx and fx, if you multiply x to the power 2 by x to the power 2, fx will start from x to the power 4. Now, in front of x to the power 4 of fx, you don't have a coefficient, which means it looks like fx equals x to the power 4, yada yada yada. Now, gx is actually 6x to the power 4. Now, since these have the same root, we can say that this fx, if you multiply by 6, this will be equal to 6x to the power 4. Everything will be multiplied by 6. Then you can say that since these have same root, since fx equals 0 and gx equals 0 has same roots, we can say 6 times fx is equals to gx. 6 times fx is equals to gx. So 6 times fx, so I will first of all consider fx. Yes, fx is x to the power 3, sorry, x to the power 4. X to the power 4 minus bx to the power 2 plus x to the power 3. Yeah. Okay, then multiply this by alpha minus alpha x to the power 3 plus alpha beta x to the power 2 minus alpha x. Multiply everything by 1 plus x squared minus beta x plus x. So fx is actually equals to x to the power 4. You take minus out, alpha plus beta x to the power 3. When you consider x to the power 2, it's going to be 1 plus 1 is 2 plus alpha beta x to the power 2. Okay. When you consider x, it's going to be take minus out, alpha plus beta x plus 1. Okay, so 6fx is going to be 6 times this. So 6 times x to the power 4 minus alpha plus beta x to the power 3 plus 2 alpha beta x to the power 2 minus alpha plus beta x plus 1 equals to gx, which is, we'll write it later. Okay, 6x to the power 4 minus 6 times alpha plus beta x to the power 3, 6 2 plus alpha beta x to the power 2 minus 6 alpha plus beta x plus 6. This is equals to 6x to the power 4 minus 35x to the power 3 plus 62x to the power 2 minus 35x plus 6. Now I am going to erase this right hand side because I don't need this anymore. Okay, then I can compare coefficients. If I compare coefficients, we can compare the coefficient of x to the power 3. You can see that minus 6 times alpha plus beta will give you right hand side minus 35, which means alpha plus beta equals 35 divided by 6. When you consider x to the power 2, you can get 6 times 2 plus alpha beta is equals to 62. Now, open brackets, 12 plus 6 alpha beta equals to 62. 6 alpha beta equals 50. Alpha beta equals 50 divided by 6. Now, what we want, we have alpha plus beta and alpha beta. Okay. So, what is the question they are asking? They are asking us um, to find the roots of the equation with the roots alpha and beta. So, we know if you want to find the equation, that equation with alpha and beta as roots is x to the power 2 minus alpha plus beta x plus alpha beta equals to 0. Now substitute these values. X to the power 2 minus alpha plus beta is 35 over 6 x plus 50 over 6 equals to 0. Multiply everything by 6. 6x squared minus 35x plus 50 equals to 0. Thus, we have got the answer we want. Okay, now if you read the next question, they are asking you to hence, which means this is interconnected to the previous part. Find all the roots of the equation gx equals 0. So the first thing we need to do is we have to find this alpha and beta. We have to find this alpha and beta. Now alpha and beta are the roots of this equation. So this is a quadratic equation, which means you have only two roots. So if you find the roots of this equation, these would be equal to alpha and beta. So we are writing that equation again. The equation is going to be 6x to the power 2 minus 35x plus 50 equals 0. Now we have to factorize this. I will go from the very baby steps. I won't write the answer at once. I will tell you how you get the answer. Multiply 50 by 6. 50 by 6, 50, 100, 150, 200, 250, 300, 300. So now you are going to factorize 300 such that you are going to get 35 as the sum. 1 into 300, not working. 2 into 150. 3 into 100. 4 into 75. 5 into 60. 6 into 300 divided by 6 is 50. Okay. 300 is not divisible by 7. Is it divisible by 8? No. Divisible by 9? No. Divisible by 10? Yes. 10 into 30. Still not what we want. 11? No. 12? Yes. 12 into 50 means 25. 13? Not possible. 14? Not possible. 15? It is possible. Yes. 15 into 20. Now if you consider 15 plus 20, we get 35. So this is the combination we want. So if you consider 6, 6 is going to be 1 into 6, 2 into 3. So I'll put two brackets here. Now 6 multiplied by any real number, will it give you me 15? No. 6 multiplied by any real number, will it give me 20? No. Which means this is not an option. This will be the option. 2 multiplied by any number, will it give me 15? No. But we can get the same thing by 3. So I will put 3 here. 3 multiplied by 5 will give me 15. And 2 multiplied by 10 will give me 20. So I'll put here 3x and 2x. 3x into 5. 3x into 5. 2x into 10. Both should be minus. Okay. Then 3x minus 10 equals 0. X equals 10 over 3. 2x minus 5 equals 0. X equals 5 over 2. So the interesting part of this is, it doesn't really matter what you take it as alpha and beta, since the symmetry of fx is equal. Look at this. Here alpha, beta, same place, same way. Okay, it's symmetric. If you switch alpha and beta in this equation, you will still get the same fx. So whatever values of alpha and beta, you can take one of this, no problem. So we'll take alpha equals 10 over 3 and beta equals 5 over 2. Okay, now they are asking you roots of gx equals 0. I'll erase these parts because I don't need this. You can forward the video if you want. Roots of gx equals 0 should be equal to the roots of fx equals 0. That is what they are asking, right? See, find all the roots of the equation. They are telling that if both fx equals 0 and gx equals 0 have the same root, they are having the same root. So therefore, we'll find the roots of fx equals 0. Then if you consider fx equals 0, now fx is going to be um, fx is going to be x to the power 2 minus alpha x plus 1, x to the power 2 minus beta x plus 1. That is x to the power 2 minus 10 over 3x plus 1, x to the power 2 minus 5 over 2x plus 1, 3x to the power 2 minus 10x plus 1 plus 3 actually. 2x to the power 2 minus 5x plus 2. Okay. Now this is a quadratic equation. This is the quadratic equation. You can factorize this into 2. 3 into 3 is, so you get 3x and x. Okay, for you to get 10, you can get here 3, here 1, minus minus. Same thing here, 2x and x, 2 and 1, minus minus. So fx is equals to 0 now, which means 3x minus 1 equals 0, x minus 3 equals 0, 2x minus 1 equals 0, x minus 2 equals 0. So the roots are fx equals 0, which is equals to roots of gx equals 0 is equals to x equals 1 over 3, x equals 3, x equals 1 over 2, x equals 2. These are the roots of the equation gx equals 0. Because it's x to the power 4, the maximum amount of root you can have is 4. So you have 4 roots here. Then the next question, if you consider, then the Roman 2 part of this particular question, quadratic itself, Roman 2. If fx is equals to hx, find possible values of alpha and beta and show that the roots of the equation hx equals 0 are not real. Now this is different from the previous. This has no interconnection. They are telling fx is equals to hx. Okay. Now the value of fx is x to the power 4. I have it here. x to the power 4 minus alpha plus beta x to the power 3, alpha plus beta x to the power 3, 2 plus alpha beta x to the power 2, alpha plus beta x plus 1. This is equals to x to the power 4 plus x squared plus 1. Okay. Now compare coefficients. Okay. So minus alpha plus beta, if you consider x to the power 3 comparing coefficient, that is equals to 0. So alpha plus beta equals to 0. Okay. Then if you consider x to the power 2, 2 plus alpha beta equals to 1. Alpha beta equals 1 minus 2 is minus 1. So alpha equals to minus beta. Okay, let's say beta equals to minus alpha. Beta equals to minus alpha. Alpha times minus alpha equals minus 1. Minus alpha squared equals to minus 1. Alpha squared equals to 1. Okay, alpha squared equals to 1. Now, if alpha squared equals to 1, alpha should be equals to plus or minus 1. Now, alpha plus beta equals to 0. No? So, alpha equals minus beta, which means when alpha equals 1, beta equals minus 1, alpha equals minus 1, beta equals 1. Basically, you can say alpha equals plus or minus 1, beta equals to minus or plus 1. Okay, this is the case. Okay. Now, let's take one is the other. So, we'll take alpha equals 1 and beta equals minus 1 because this could be possible even if you interchange it, the value of fx won't change. So you can take fx as x to the power 2 minus 1 x plus 1 x to the power 2 plus x plus 1. Now since fx equals to hx, okay, if you consider the roots of hx should be equal to the roots of fx, equal 0, equal 0. Roots of hx equal 0 should be equal to roots of fx equal 0. Now, if you consider fx, okay, we know that x squared minus x plus 1, if you consider the discriminant here, b squared is 1 minus 4ac, 1 minus 4 is minus 3, discriminant is negative. If you consider x squared plus x plus 1, discriminant is 4ac again, discriminant is negative. So, x squared minus x plus 1 has no real roots. X squared plus x plus 1 has no real roots. Both of them doesn't have any real root. So fx has wrong. Write it properly. You have to write it. You have to write an equals to 0 part. Equals 0 has no real root. Equals 0 has no real root. So fx equals 0 has no real roots, which means that hx equals 0 has no real roots. Okay, that part is finished. Next, we'll go to the B part of the question, remainder theorem and factor theorem. They are asking let fx equals to 2x to the power 4 plus gamma x to the power 3 plus delta x plus 1, where gamma and delta are real constant. Given that f minus half is 0, f minus 2 is f minus half equals 0, f minus 2 equals 21, find the two linear factors of fx. So you can say that if f minus half is 0, then you can say from that this implies that x plus half is a factor, which implies that 2x plus 1 is a factor. That is one linear factor. Now you need to find this gamma and delta. So f minus half is 0, which is equals to 2 times minus half to the power 4 plus gamma times minus half to the power 3 plus delta times minus half plus 1. 2 into 2 into 2 is 8. You get 8 here. Plus 1, 9. Minus gamma. Okay, I made a mistake here. This will be 2 into 2 into 2 is 1 over 8, because 2 and 1 of the 2 is cancelled off. Minus gamma over 8. Okay, so you can multiply this by 4, multiply the top by 4, plus 4 delta over 8. Delta, and this looks like plus 8 over 8 equals 0. Multiply everything by 8, you will get 0 equals to 1 minus gamma plus 4 delta plus 8. This should be minus actually. Okay. Okay. Then you can say that this is minus now. Then you can say that 8 plus 1, 9. Put this to this side. This plus gamma. This is equation 1. Then you can say f minus 2 equals 2 into minus 2 to the power 4 plus gamma into minus 2 to the power 3 plus delta into minus 2 to the power 1 plus 1. Now this is equals to 2 into 2 into 2 into 2 into 2 is 32. This is equals to 21 this side. This will be minus 2 into 2 into 2 is 8 gamma minus 2 delta plus 1. So 8 gamma plus 2 delta equals 32 plus 1, 33 minus 21. 3 minus 1 is 2, 3 minus 2 is 1, 12. 8 gamma plus 2 delta. 8 gamma plus 2 delta is this. Which means if you multiply this by 2, 16 gamma plus 4 delta equals 24. So if I deduct 2 minus 1, 16 gamma minus gamma is 15 gamma, 4 delta minus 4 delta is 0, 24 minus 9 is 15, which means gamma equals to 1. If gamma equals 1, 4 delta equals 9 minus 1, 8, this is by 1. You can do it by 2 also, which means this equals to 2. So now you have fx equals 2x to the power 4 plus x to the power 3 plus 2x plus 1. Now 2x to the power 4 plus x to the power 3 plus 2x plus 1. You divide this whole thing by 2x plus 1 because 2x plus 1 is a factor. Okay. Within 2x you have x to the power 3 here. So you have 2x to the power 4 plus x to the power 3. 0. You have 2x plus 1, which means plus 1. So you can write fx as 2x plus 1 x cube plus 1. 2x plus 1 x cube plus 1 is x plus 1 x squared plus x plus 1. This is direct theory. So these are the two linear terms. Okay. The question they are asking is find the two linear factors of fx. So we can finalize the answer like this. Or you can write a separate sentence to the two linear factors fx are 2x plus 1 and x plus 1. Okay. Question number Roman 2. Find the two linear expressions px and qx satisfying the equation. They have given you this equation. x to the power 2 plus x plus 1 times px plus x squared minus 1 times qx equals 3x. We'll take px as ax plus b and qx as cx plus d. Now your job is to find a, b, c, d. X to the power 2 plus x plus 1 ax plus b, x squared minus 1 cx plus d equals to 3x. When x equals 1, this will be 1 plus 1 plus 1 a plus, wherever you have x put 1. X squared means 1 squared minus 1 is 0, which means this whole thing becomes 0. So 3 times 1. 3 a plus 1 equals to 1. When x equals minus 1, 1 minus 1 plus 1 minus 1 plus b, like this. Plus this becomes 0, so you have minus 3 here. This and this cancel off, so b minus a equals to minus 3. Now if I add the first equation with the second equation, b plus b is 2b, a and a cancel off, minus 2, so b equals to minus 1. If b equals to minus 1, a minus 1 equals to 1, a equals to 2. So a equals 2, b equals 1. I'm having x squared plus x plus 1. Is it plus no minus 1? It's minus 1. So I'm having here ax plus b, so 2x minus 1 plus x to the power 2 minus 1 cx plus d equals to 3x. Now open brackets, um, 2x to the power 3, 2x to the power 2 plus 2x minus x squared minus x minus 1 plus cx to the power 3 minus cx plus dx squared minus d. This is equals to 3x. 2 plus c x to the power 3 plus 2 minus 1 is 1, so I can put 1 here. Any other x squared? Yes. X to the power 2 plus 2 minus 1, which is 1, minus c x plus, the constant terms are going to be minus 1 minus d. Is it correct? Okay, so this is equals to 3x. Then we know that 2 plus c is equals to 0, which means c equals to minus 2. We can confirm this with this. This is x to the power 3. We can confirm it with x if you consider 1 minus c equals to 3. Okay. 1 minus 3 equals c, c equals minus 2. Both are confirmed. X to the power 2, 1 plus d equals 0, d equals to minus 1. We can confirm it with x to the power 0. This equals to 0, 1 plus d equals 0. You are basically getting the same thing here. Okay, so I can take px as 2x minus 1 and qx as minus 2x minus 1. So we have successfully found the two linear expressions px and qx satisfying the equation what they have given. This would totally give you 150 marks. So that's all for today. That's all for this video. So if you enjoy the explanation, the clear explanation, and if you have learned something new, please like this video and subscribe to the channel and share this video with your friends.